Okay, day 3. Eggs are packed in by the dozen. How many dozens can be packed from 624 eggs? Use 2 different strategies. Strategy 1, strategy 2. As you can see, I did partial quotient on this side and I did an area model. The students understand this, parents, so this explanation is a little bit for them, and but mostly for you because I know that we didn't solve this way when we were in school. Okay, so I have 12 on the outside, just like we would normally set up division. Instead, I drew a very long line over here. Okay, now I think of how can I make this 12, if I multiply something, how can I make it a 3-digit number? I can multiply it, and I like to use either multiples of 10 or multiples of 100 or 1,000, depending on how big my number needs to be. Okay, so I thought about 12 times 5 would give me 60. So 12 times 5, but if I add a 0 to that 60, it gives me a 600. And that's what I did, is I multiplied 12 times 50. So 12 times 50 is 600. Now I do repeated subtraction where I subtract. 624 minus 600 gave me 24. Well, right away I can see, oh, I know what 2 times 12 is. It's 24. So there's my 2. 2 times 12 is 24, and now I subtract 24. I have 0 as a remainder. I add my 2 partial quotients, and I get 52. All right, next strategy, I use the area model. All I do with area model is I distribute my number or decompose my number. So the students know this best as expanded form. I take my 600 and 24 and I separate those out. Now I don't separate this into 20 and 4 because 12 cannot evenly divide into 4. So I leave that number whole as I possibly can to leave room for 12 to divide into it. So I have 600 plus 24, which would give me back that same dividend, which is 624. So I just split it up in the area model. Now what I do is I divide 12 into 600, and I know that 12 times 5 is 60. So I add 1 0, and now I have 600. 50 times 12 is 600. I look over here at my 24, and now I divide 12 into 24, goes 2 times. I add up my 2 quotients, and I get 52. Use what you do know about multiplication to determine which of the following could have a quotient greater than 100. Again, this is just like partial quotient. I have to have a number that's small enough to subtract from this number for me to use a 100. So if I look, 67 times 100 would give me 6,700, which is too big to subtract. So I know it won't have a quotient of 100. I have 87, and if I multiply 87 times 100, I get 8,700, which is too big. This number also becomes too big to subtract from 72,000. The only one that is less would be A. Write an expression for the following. Jason had 41 model airplanes in his collection. He gave 12 to his cousin and then bought 9 more. So I have 51 minus 12 because first he had 51 models, then he gave 12 away, so I show that with subtraction. I used parentheses. I did not have to because GMDAS tells me that I subtract first and then add, but I like to make sure that I use all of my groupings and group when I want to tell someone, please do this step first. So I used a grouping, and then I added 9 because he bought 9 more. All right, this is using a number line, which we have just begun. So parents, be a little patient if they don't really understand this fully because we just began this. During PE, Jade ran a mile and 7 and 36 hundredths minutes. Complete the number line to show how you can use it to round her time to the nearest tenth. So this one is broken up in tenths already and not hundredths. So as we're going to continue discussing this week and a little bit of the beginning of next week on how we can always zoom in more on a number line. So what I did was I found the halfway point between 7 and 3/10 and 7 and 4/10, and I just drew 7 and 35 hundredths because I know that 5 is halfway between It's like a midpoint between 10. So for that other hundredth, I just made sure I put it in the middle, okay? Since I have 7 4/10, I have 7 45 hundredths, because that 5 lets me know it's halfway between 7 4/10 and 7 5/10. Okay, so I'm just going to show you that for just a second. Now all I did was just use those 2 points that I plotted to help me to determine how close their times were to the nearest tenth. So 7 43 hundredths is very close to 7 4/10. And 7 36 hundredths, which would be right on this side of 7 35 hundredths, is closer to 7 4/10. So if I'm rounding to the nearest tenth, both of them came with the 7 4/10 time. But who ran faster, in all actuality, using an exact time, would be Rachel.